This video demonstrates my final project, which is a data and structural hazard detector for pipelining. I've created two files, simple.asm, which has a simple data hazard on the load word register 1 here, and all the operations that depend on it, and then branching, which is basically our midterm exam. However, we have this loop here. I'm going to essentially show what happens when I use it for pipelining. I unroll it. Basically, I predict branch not taken to show what sort of effects there are for data and for structural hazards if we unroll the loop and continue execution. Okay, so we'll start with parser.py. Parser.py contains the actual regex to parse the instructions. These are modular different components that make up our instructions right here. Those get parsed into different types of actual instructions, and then finally ultimately instantiated in parsed instruction. Parsed instruction is what is used by hazard.py to kind of detect hazards. Hazard.py maintains state in this class right here. It has a graph node. Each node in the graph is a register that is available. And available here has a special definition. Available doesn't mean the data has actually been computed and ready yet. It actually means that any instructions that depend on that register can begin to proceed without danger of a data hazard. For example, if I'm in an instruction, I'm in the ID stage, instruction to code, and my target register that I'm saving to or writing to is register 1, and I have forwarding enabled, I can flag register 1 as available because my next subsequent stage is going to be ALU execute. From there, I can forward my result output to whatever dependent instructions there are. So any dependent instructions can actually begin instruction fetch. That's what I mean by available here. All right, now the majority of the checks are done in increment stage. All the different checks here, you can look at the documentation to explain kind of what sort of checks are being enabled. But actually, let's take a look now on what will happen if we just run this without any sort of features enabled, no forwarding or separate memory caches. Okay, so what you see here is load word starts register 1, but that doesn't become available to the write back after the write back finishes. Just like in question 4 of the midterm, it won't be available until after that stage. Therefore, there's going to be a lot of data hazards at first. You see all these data hazards here. They're waiting on R1, as it says. And then after even R1 is available, there's structural hazards because there's only one memory cache. There's no separate instruction and data memory cache. There are structural hazards as and, or, and dsub begin to execute. Therefore, you'll see it takes about 12 cycles, 11 plus 1, for this to actually complete. Now let's go back and see what will happen if we enable both forwarding and as well as separate memory caches here. Okay, you can see there's only actually one hazard, and that's coming from the stall from after load. Load, remember, takes one extra stage. It doesn't become available till after the memory step. So therefore, dsub needs to wait and stall, even with forwarding, for this to be safe. Now let's take a look at what will happen during branching. So these are our more complicated scenarios here. So I'll comment in this one and make the initial available registers here different. And you can see the code here. We have add. So add is basically just adding two constants into R0. And if we have forwarding enabled, we shouldn't really see any sort of stalling happen with BEQ because we can forward it directly when we get to that instruction to code stage of add. Let's see if that's true. Okay, cool. So our first cycle, instruction fetch starts for add. Second cycle, instruction fetch is, add is now an ID. And that means that the very next cycle, register 0 will be available. Therefore, BEQ can begin, which is when it was scheduled to begin anyways. And as soon as it begins, it assumes basically branch not taken. So we move on to the next one, which is load. Load register 9. Register 9 becomes available during the memory step, even with forwarding. But that is okay because there's nothing here that really depends on R9, except for store word, which comes significantly later. So therefore, we don't really have any sort of issues with hazards, especially if we enable forwarding, and also separate memory caches for instruction and for data.